Machine learning models can do a lot for us, but much of our experience with them is mediated by interfaces. When we utilize interpretability tools, what we learn is mediated and circumscribed by the affordances those tools provide. My guest today, Martin Wattenberg, seeks new ways that technology can spark connection, insight, narrative, and beauty. Towards that goal, he's worked on visualization throughout his career and on interpretability in his capacities at Harvard and as co-founder of the People Plus AI research team at Google. From creating some of the earliest pieces of interactive journalism to developing interpretability and visualization tools for today's state-of-the-art ML systems, Professor Wattenberg has thought more deeply than most about questions of interaction and interface design. I feel really fortunate to have had this conversation with him, diving into how he thinks about interaction and interfaces, both in and out of ML, and what he hopes to see in the AI world going forward. While I'm still here talking, two quick things that I wanted to note. You'll see this first one in the interview, but I did fail to review an important detail in the Kenneth Lee paper on OthelloGPT that we discussed about causality in world models. You'll hear what I'm talking about in the conversation. This led to a rather silly question line that I began, and Professor Wattenberg graciously pointed out that detail, as well as a better version of the kind of skepticism I articulated. Second, I'm trying to be a little bit better on attribution when I bring up papers. I do try to mostly draw up papers that my guest was a first author on, but we often also discuss papers that they just made contributions to. Jonathan Frankel called me out on this a few times where I wasn't careful to note that he was an author on the paper I asked him about, but wasn't necessarily the person who had come up with the idea or done most of the work. In the context of a podcast episode focused on somebody's work, these details can be pretty important. So I'm aiming to do better with that in future episodes, and hope I'm starting to do better with this. And as always, if you have feedback, want to suggest things I can do better, please do leave comments or send email. We also do really appreciate your reviews on Apple or Spotify or wherever you're listening to this. They really make my day personally and help us out a lot. This is the Gradient Podcast, and I am your host, Daniel Bashir. If you enjoy these episodes, you can follow us wherever you're listening to this podcast episode. You can also follow us on Substack to get regular notifications whenever we release a new article, newsletter, or podcast episode. You can also find our online magazine at thegradient.pub, where we regularly publish essays by the sorts of people I interview on the podcast. But now, without further ado, Martin Wattenberg. Professor Wattenberg, I think you've been doing probably some of the most interesting work I've seen in visualization and ML. I know that you've worked with one of my previous guests, Bean Kim, on some really cool work related to interpretability. And in looking at your background, though, it does seem like you've done some other really, really interesting things. So I'm curious to hear a little bit about your background and how you got into AI in the first place.
Yeah, well, first of all, thank you for having me here. I'm delighted to be on the podcast. My background, it's interesting. I look at some of my colleagues and I feel like their CVs look like a triumphal march. And my own CV, I think, looks much more like a ball bouncing around in a pinball machine. So I started out, I got a PhD in mathematics at Berkeley. I loved mathematics, still do. But right as I was graduating, the web was starting to take off. And I just got really excited by the possibilities of web publishing. I was like, I think this thing is going to be big. Maybe we'll all be on the internet someday. And so I ended up working in financial journalism, working on a website for a magazine called SmartMoney that Dow Jones and Hearst put out. And that was sort of that was my first big pinball bounce, as it were, into a new field. And while I was there, one of the things that I discovered, I should say we, because there was a great team there, was that if you could visualize, just in terms of charts and graphs, what was going on in the market or for a personal investment decision, that made a huge impact on people who are reading the online magazine. They could understand all sorts of complicated things that were just hard to get across in pure words. And so that sparked an interest for me in data visualization. And I started doing fancier and fancier charts and graphs, weirder and weirder things. Eventually, I sort of made contact with the academic data visualization world through some of the things that I did, and began to think, okay, I really want to study this full time, make this my career. So then I ended up at IBM, IBM Research. Did a host of visualization research there. A couple key things I would say is one is that I was in a group that was related to collaboration. It was run by a woman named Irene Greif, who pioneered the idea that when we think about people using computers, it's not just a matter of a single person using a single computer or a single person using a cluster, but many people using computers together, and that the dynamics of multiple people are really complicated and important and interesting to study. That, I think, has infused a lot of my work since then, both in visualization and in machine learning since then. Then I also started collaborating while I was at IBM with Fernanda Viégas. So she and I first did some work studying Wikipedia, but at this point, it's, I think, roughly 20 years later, and we're still collaborating. And as I talk about the work I've done in the rest of this show, I would say the vast majority of it was done with her as a collaborator. So from IBM, actually, Fernanda and I started a small startup doing data visualization, but then Google came to us and basically made a very convincing case that we should come to Google Research. We started a data visualization group there, and then what happened there is we talked to more and more people who are interested in visualizing machine learning systems. And so around, I don't know, maybe 2014, 2015, we really began to do this transition into visualizing machine learning, and eventually ended up as part of Google Brain in its relatively early days. And that was really where I feel like I got into machine learning for real. I will also say that I had a brief spate of interest in machine learning in college. So very long ago, I even took a course in neural networks. And this was in the 1980s. So this was really the olden days, as it were. And I remember at the time just loving the topic so much, and yet feeling like, oh, I don't know, maybe the whole thing is just a dead end. Do I really want to bet my career on this? I guess I better study something else. But, in retrospect, I'm like, what would have happened if I had stuck with that, But all's well that ends well, I guess.
Yeah, in the 1980s, I don't know exactly how the decades line up, but it's sort of the very well-known story that Hinton and LeCun and all these others were sort of continuing to riff away at this during the late 1900s when really nobody was thinking about it. I'm curious, when you were taking this neural networks class, if there was maybe a degree of skepticism about things, since we hadn't quite hit the point where things weren't working well or were working well.
Yeah, I'm trying to remember the dynamic exactly. I think this was post back propagation. I remember Jeff Hinton's name coming up for sure. I think there was some level of skepticism just because it felt like a very niche topic in the grand scheme of things. And the other thing that was true is that there was just very little computing power. Like, there weren't any dramatic examples of neural networks accomplishing anything amazing. And often they were used to simulate sort of other cognitive systems. I remember, people would try to simulate how humans do multiplication or how humans learn languages. And there were these really intriguing results, but there was not the sort of marquee practical results that we started seeing, in the 2000s.
Sure. I want to go through maybe a couple of specific examples of the work that you were doing through this arc and maybe beginning early on. You mentioned your work at IBM Research, for example, and there I know with Danielle Fisher, you'd worked on this multi-scale model of perceptual organization. And I think what kind of stuck out to me and what felt really interesting there was you're thinking about this intuition of multiple scales in information graphics. And you use this quotation from Burton at the beginning about a graphic kind of not only showing the leaves, but also the branches, the entire tree. I guess I'd love to hear you speak a little bit about just how you think about these facets of the organization, the design of graphics, the multiple scales, what are maybe good and bad examples of this sort of thing.
Yes, absolutely. I think this connects to a bunch of through lines in my career, as well as some interesting dead ends, I would say. So to begin with, as I was designing visualizations, I kept, the question is always, how can we design them better? How can we do things that are really effective in making people feel smarter? And in order to do that, you pretty quickly realize, oh, I need to understand something about what's going on in people's heads. What is their mental model of the world? What is vision doing? Like, what special powers does our visual system have? And so one of the things that becomes clear when you start doing design is exactly this idea of hierarchy. And this is something that I still try to get across in any design class I teach, or working with students on creating diagrams, is that when you first look at an image, you see, large structure, then your eye will sort of traverse it in certain ways, and you can then pick out a part that you're interested in. You can look at, smaller things. And if you have a well-designed diagram, you can organize a huge amount of information that way and basically guide a person's eye to what is most important. So this is all sort of designer intuition, which I certainly did not make up. This is, known by designers informally for a very long time. One of the things I was trying to do with this paper is formalize that and say, okay, can we actually take some, relatively sophisticated geometrical techniques that been developed for computer vision, a notion of scale space, come up with an actual model of what might be in your head or what a designer might think of, and then surface that to someone who is designing a visualization. So I think the good news about that paper is that we actually were able to come up with a model that matched our intuitions a little bit, that was able to give the right answer in some simple cases. And I felt like that's an interesting direction to go. However, I will also say in the process of writing this paper, it just became clear to me that I was hoping for way too much in our then understanding of the human visual system. Like, there was no way that I was at that point going to write a program that would simulate what goes through someone's head when they see a data visualization. And in some ways, I feel like one lesson I learned from that is that you can't have too high a hope for just a quantitative answer to everything. At some level, in visualization design, you have to rely on qualitative studies. You have to rely on designer intuition. For the moment, at least, there's no way around it. Maybe this will all be changed in a couple of decades or something. But, for me, coming from a mathematics background where I felt like, of course you want everything to be quantitative. Of course you want everything to be mathematical. This was one of the points where I really learned, okay, you can try that. You can push that pretty far. But at the end of the day, if you really want to understand what's going on, qualitative understanding, just talking to someone and watching them use a visualization for 5 minutes is probably going to be more informative than plugging the image into a fancy mathematical model.
And there have been a lot of great studies recently, I think, that we'll get to this, I think, when we talk about some of the more ML focused work, but how people look at interpretive visualizations of neural networks and things like this, and how they may or may not actually sort of understand better what's going on in there and be able to use that for predictions. Before we get to all of this, though, I am curious just on the perspective of a designer. One thing you mentioned about this is that you can pack a whole lot of information into a well designed diagram or something of this sort. How do you think about that balance between, well, I want to pack in a lot of information or a lot of relevant information, but I also don't want to overwhelm somebody with just throwing too much at them?
I think the best way to kind of attack that question, and it's a very good question, is to think about who your audience is, because different audiences really respond in different ways. So if your audience is encountering complicated information for the first time, and I'll give you an example. Imagine someone who's planning for retirement. So this is something that we thought about when I was at SmartMoney. I watched other people design retirement calculators and retirement predictors. That's really overwhelming to a lot of people. And very frequently, and the truth is that, predicting the future is incredibly hard and there's so many variables, and it's really tempting to just put all of those variables into one big worksheet. That is very off-putting for a lot of people. And frequently you can get a lot of the value, just give people a sense of, okay, look, you're going to need to save money. Here's what's going to happen. Here's what it means to draw down savings with relatively few variables. And that's very typical, that if you're introducing something for the first time, maybe someone is only going to see something once, that's when you want to really aim for simplicity in the sense of relatively sparse, carefully curated information. On the other hand, there's another kind of chart you might use, which is for someone who is monitoring something, who looks at that all the time, becomes an expert in the field. Maybe it's like they look at their stock portfolio and they just want to know they look at this thing every day, or they're just a data analyst. It's their job to look at a lot of information, trying to understand what's going on. In this case, you want to put as much information as you can on the screen. And every person I've worked with who is an expert, who is looking at things, I've never heard anyone as an expert say, I want to see less. What you do want to do, though, is organize things so that they can find it relatively easily, so that it makes sense. But in a sense, I don't think there's a right answer to how much information should I put on the screen until you start looking at who the person is who is going to be using your visualization.
One thing I notice in some interfaces I use is kind of an analog of something that Francois Chollet often says about Keras, this design principle of a progressive disclosure of complexity, where you begin with that very simple thing that might be targeted to somebody who doesn't have a lot of expertise in your area, but then kind of optionally in the affordances of that same interface, you can click through into something where you do want to learn more detail. Is that something that you think about and kind of incorporate into your design thinking as well?
Yeah, progressive disclosure is a very good technique, and it works well in a context where someone is moving from one type of audience to the other, I would say, because basically you're going along with them and letting them control things. I do think that typically people will underestimate how much information people can handle. Like in general, I think if I had to give one piece of advice to people who are starting to create their own visualizations, it would be show more data rather than less data. The biggest mistake is people try to make things too simple, more than anything else. The thing that I would also add there is that there's also a distinction between data analysis and communicating a point. And often when you're communicating a point, you can make things much, much simpler, because you just can, there's interesting information, but it's just not relevant, and you can take it away because you know what you want to communicate. On the other hand, when you're giving people data to analyze, you don't know a priori what's going to be useful. And so that again, that's the case where I'd say give them a lot of information.
Right. And I guess in many ways, this is really a goal directed problem for a specific audience. When you speak about picking out relevant information to communicate a point, then you're also kind of bringing in, well, maybe I'm serving this up to a specific audience. I, as the person who is designing and choosing what information, what data is actually relevant here, I am making a kind of editorial decision on that point as well.
Exactly. And in fact, this gets to another whole very interesting thread in the visualization world, that it's ultimately a rhetorical process. And, unless you're designing some pure data analysis tool, and then probably even then, but if you are, say, at a newspaper and you are creating a visualization to accompany a story, that's rhetoric. You're making decisions about what to include, what is important, what is not important. And it's always important to keep that in mind also as a reader. what do they leave out of the visualization? How did they choose the bounds on that x-axis? Why did they start at that year? That's almost always a tell, by the way, because frequently you can make any time series. You can really change what the message is with a time series by choosing the date boundaries. And so you can often tell what people are trying to get across by looking at that carefully.
Sometimes you'll see these kind of horrendous estimates of performance. I think I've seen this in the case of maybe hardware systems where they'll compare something like throughput, and on the graph, one of the bars just looks, 20 times bigger than the other. But then you actually look at the scale they're looking at, and it's like, okay, they cut off the whole bottom of the graph, and this is like increments in 0.01% or something. So on an absolute scale, this is actually not that big of a difference, but they've just really fudged the graph to kind of make you think this is way better.
Yes. Yeah, that is a famous way that things can go wrong, and there's a ton of things like that. Yeah.
Another example of an interface you worked on at IBM that really interested me was this conversation thumbnails for large scale discussions with David Millen. And I think what was really cool about this was some of the different attributes that you looked at that didn't seem to exist in current conversation interfaces that still feel like things that I don't know if I see those to the extent that you were thinking about them at the time. I suppose I'm probably not the only person who has frustrations here and there with conversation interfaces, and that something like Slack, for example, as a workspace, it has its uses, but it's so easy for things to get lost. I think that Cal Newport has like this entire different line of complaints about Slack as kind of the hyperactive hive mind. And so I'm curious how you were thinking about the conversation interfaces at the time, but then also maybe looking forward and bringing some of that insight to today. If you feel like the conversation interfaces we have now, things like Slack, like Discord, whether those represent the kind of market improvement that you might have wanted to see.
I think that's a great question. If my past self could have had a glimpse of what the current state of affairs is, I think there's one thing that I probably would have been happy about, which is the fact that people are including all sorts of images in their conversations now, and I think that sort of keeps it from being completely gray and dull and adds a lot of visual interest. But I think you're right. I also might have been a little depressed that we're seeing the exact same thing, even though I think about, I believe the conversational thumbnails site, one of the things that I remember looking at that in was, the site Slashdot, which was, I think it still exists, but at the time it was sort of a gathering place for all sorts of coders and people who love Linux and so forth. But today, Reddit looks almost exactly like that interface. And it's not clear that we have an improvement. Like if you're looking at a really, really long Reddit thread, I think that I would actually love to see someone revive this interface. I think one of the things that has happened is that people themselves have changed their behavior, and that people are much better at skimming now for two reasons. One is that I think just the way that we read online has changed a lot. Like people were skimming already, I think a couple decades ago, but at this point, it's just become a habit for us. The other thing is that the physical act of scrolling is far, far easier now. Because it used to be actually scrolling was this really painful thing that involved either clicking a lot of keys or like the actual acquiring a target with a mouse and pressing down and moving a little bit. Today, it's just sort of you're swiping. And I think it's an interesting example of how sort of the input devices maybe affect some of the output we see. And then another factor is that everyone's on their phones, and that the kind of interface that is in that conversational thumbnails paper, where you see like this very crisp, clear visualization of the entire conversation and are using that to navigate, that works beautifully on a large monitor. It does not work so well on a phone. Uh, and so I think that's one of the other things that we're contending with visualizations is how do we make them work on a small screen?
One thing I'm noticing in a lot of what you said is this kind of path dependence going on here. You mentioned the way that people's behavior has changed, that we've gotten better at skimming. And yes, I think the phone becoming such a big thing is a huge part of this as a device. But you can also kind of see, I think, in what you're saying, that some of the specific affordances of the conversational interfaces we built and the readers that we have perhaps directed our collective ways of reading things and what we seem to be better at. And it feels like, I know it's kind of hard to sort of evaluate counterfactuals, but it's like I can kind of imagine a world in which maybe a conversational interface like the one you proposed then actually worked. And maybe if that were widespread, then the things that we're good at or the ways we navigate interfaces collectively look a little bit different today. Is that something you could also imagine?
Absolutely. I think that there is exactly that kind of path dependence. And I think as we talk about machine learning, it's really important to keep that in mind. I think that the two lessons here are one, that people's behaviors will change, that just as the technology changes, and we shouldn't assume that the way people use something like chatbots today is going to be anything like what it is in 10 years. And that change may not be something that, is under my control. It may be that, a set of, forward-looking teenagers, like so many other things in culture, end up setting the way everyone else interacts with it. So that's one thing. But I think to your point, there's this interesting possibility, which is that one way we might affect how people use machine learning, if we want to affect it, is to come up with an interface that has affordances for the kinds of behavior we hope people will do, and maybe makes it harder to do behavior that would not be so good. Designing those interfaces is a whole complicated thing, but we can certainly talk about that too.
Before we get more in detail into that, there were two other projects of yours that I wanted to talk about. And one of them was this baby names and social data analysis that you worked on. And I know this was created to celebrate the launch of your wife's book. I'd be really excited just to hear you talk a little bit about that project.
Absolutely. So the baby name visualization, this is something I absolutely will credit my wife as a collaborator on. This is something that the two of us worked on. So she is a baby name expert, and she has written a book called The Baby Name Wizard. When she launched it, we wanted to sort of celebrate it, and we created this visualization that lets you type in a name and you see this sort of smooth animation, which at that point actually was sort of technically unusual. This is all using Java applets, a sort of dead technology at this point. And you could see that, but the effect was this very sort of, I don't know, pleasurable experience of exploring name data. By the way, if anyone wants to see a modern version of this, you can go to her site, numerology.com, and it has a name grapher that looks very much like the original. So the interesting thing that we noticed is that I think both of us had assumed that people who are interested in names were likely to be expectant parents. And what we would see is that people trying to name their kids would use this. So we did see that. But something else happened that was really surprising is all of these other people around the internet started using it. They would write about it on blogs. They would write about it in discussion groups. Sometimes they'd be very explicit. They're like, I do not like children, and I'm still interested in this. So they were not expectant parents. And they would start finding things in the data. And it was this sort of surprising and cool situation where the set of data that this thing was showing was basically many thousands of names, and there were sort of time series over the past century, roughly, of their popularity. And there's a lot of patterns in there. Many of them quite subtle. A lot of them come to bear on sort of how our culture is changing. And people collectively found a lot of these patterns, and they would go back and forth. They would give each other little challenges. And this ties into this idea that I mentioned before around there being this interesting difference between groups of people using a computer or computers versus just one person, because there was like a collective dynamic around data analysis where people were collectively finding much more, I think, than any individual person would have found. And this became something that for me, it was sort of an inspiration of, okay, what can we do with the collective power of people analyzing data together? I also will credit my collaborator, Fernanda Viégas, with having a lot of these ideas very early, and probably possibly earlier, where she was looking at visualizations and seeing very similar things, that they were sparking conversations. And then those conversations and the storytelling around them turned out to be a major part of the experience around the visualization, a major part of the value that they brought.
I think this question of sort of cooperation and collectively looking at things is maybe a good segue into your history flow paper. And this was something you worked on with Professor Viégas as well. I'm curious about sort of the genesis behind this project. Why did you find it interesting at the time, you and Professor Viégas, to sort of investigate the dynamics behind editing on Wikipedia?
So we were drawn to Wikipedia for a couple of reasons. One is that we were both interested in this idea of looking at, I don't know, social activity on the web. This was already something we were both interested in, I would say. We had a couple of ideas before that. They didn't kind of work out for various reasons. But in the end, the truth is Wikipedia was very, very new. And there was something else about it that was interesting. It was really controversial at the time. People were very, very split on it. Of the people who knew about it, I think there were probably a few people I knew who were excited, but the majority of people I met really hated it. They thought that this was just a terrible idea to let anyone edit an encyclopedia. It's sort of like their viewpoint was, you're just going to end up with something that looks like the walls at a gas station bathroom. It's just going to be full of all sorts of crud, and you just don't want that. Why would you have all this disinformation out there? And at the same time, my experience when I used it, I found it actually pretty useful and interesting. And I just sort of, I was like, what is going on? And I think Fernanda was also, there was just a puzzle there. Like, why is it that, like, we understood why in theory it shouldn't work, but in practice it kind of seemed to. And the other thing that had going for it, which not all projects do, it had lots of data, because in their wisdom, the Wikipedia community made available a huge amount of data on the history of each page. So you got an immediate sense of exactly each version of a page, how it had been edited, and so forth.
There are a lot of really interesting things you found in the paper you published on this work, and you sort of take this very lengthy edit history, you turn into a picture. One thing that I think you specifically called out was this zigzag pattern on one wiki article that was an argument over whether certain sculpture existed or not, which I found really interesting. And one thing that was really cool about this paper, though, was sort of implications of the patterns you saw for the design and governance of online collaborative social spaces. Because it seems like, as you've mentioned, Wikipedia does still seem to be useful to a lot of us, despite the fact that I think when I was in middle school, it was like explicitly prohibited to use it as a source if I was writing an essay or something of the sort. But it still has a lot of really good information. And so it seems like, despite the kind of chaos you might expect, things are pretty, like, you can get a lot of pretty good information on there. And so I'm curious what you kind of personally took away from some of the lessons from that visualization for these design and governance issues.
Absolutely. Yeah. So I think we took a couple of things away from the paper. One thing I do want to mention is the value of visualization itself, which is that we spent a while just poking around, clicking on links in Wikipedia, looking at previous versions, and it was of articles, and it was just really hard to tell what was going on. And the moment we created this visualization, even in the extremely early stages, we just had patterns pop out at us. We could see people fighting over passages, as you described, so-called edit wars. We could actually see a bunch of vandalism, and it was amazing how the visualization just like brought that out. So that was one of the things that has sold me on visualization as a very, very useful tool. The second thing is this realization. So all of the skeptics I talked to, in a certain sense, they were all right. Every single point they made about what could go wrong on Wikipedia was going wrong. You could definitely find cases for lots of pages where it did look like the walls of a gas station bathroom, where people were posting obscene things, filthy things, useless things, offensive things. actually, they were right. All this bad stuff was happening. But then what was so dramatic was that we did an analysis, and you could also see this in the visualizations, that bad things got fixed by the community, and that they had come up with a kind of self-healing structure in which people would sign up to watch certain pages. They would get automatically alerted if things happened on those pages. And the community itself was doing a good job with the technical tools they had to sort of moderate a lot of the bad things that would happen. I will also say that another thing that became clear as we continued to do research is that it wasn't just a few technical tools that allowed this or people's whims and energy, but there were a lot of guidelines. Like Wikipedia, in some ways, when we were studying it, had after a couple of years, it became noticeably bureaucratic. Like there were lots of policies, and when people would argue about it, they would be sitting there citing chapter and verse from different pages. And that was interesting too, because that was almost the opposite of what you expect of like a freewheeling place that everyone can edit. Is the last thing you expect is a bunch of essentially bureaucracy. And yet there it was, and it actually seemed to be pretty effective. So I think there's a lot that I learned from this, like the value of transparency, tools that give you transparency, the ability of communities to take things that seem dangerous and use them in ways that actually turn out to be okay. And then also the value of a certain amount of process and bureaucracy at times. Actually, that really can work, as boring as it might seem.
It's almost surprising. You did call out this group consensus that a neutral point of view is really desirable and how that kind of provides maybe the guidelines for when people are resolving disputes about, say, a certain article or policies related to that. And even when it's not super, I guess, explicit, laid down as something like a law, it is interesting how in social spaces, even these kind of guidelines, people do seem to, of course, you have people who might detract from them, but on the whole, it seems like there is a kind of self-organization, and as you said, this bureaucracy, and it's sometimes surprising to me the way that these guidelines that are pretty soft guidelines often, but still kind of a consensus in everyone's heads, can be surprisingly effective.
Yes, I think that there are a couple of interesting points there. So one is just this idea of neutral point of view. So let's just put this out there that philosophically, that is a hard concept to defend. The idea of true neutrality in how we write about a controversial subject. Like if you go up against a good philosophy professor and try to argue that, and they're trying to argue against you, you're probably going to get blown away. And yet, it turns out that that was a really good organizing principle for actual people getting something done on the web. And it's interesting. You're like, oh, I see. So, like, do things have to be philosophically perfect to be useful in practice? Maybe not. It's sort of surprising, and I'm still thinking this through. Another thing to realize is that, does Wikipedia have a truly neutral point of view? Well, again, when you dig into it, you discover actually there are a lot of biases you can point to. There's been a lot of work on who gets represented, who doesn't. Neutral would probably be the wrong word to use for this in any case. And yet, again, all of these rules around neutral point of view did end up helping the system organize in a way that was useful to a huge number of readers. And I think what I sort of take from this is just this idea of how complicated the world is, that it's easy to come up with a simplified model that is too simple. It's also really easy to find things to criticize in everything and assume it won't work. And yet, I think that sometimes we actually are able to sort of muddle through in very complicated situations. And that gives me some hope.
I think that gives me some hope about humanity as well. I'd love to talk a little bit about your work at Pair now. And as you mentioned, you and Professor Viégas were encouraged by Google to go and work with them. And in one of the really interesting things you worked on here was tools for model understanding. And I want to use a few examples here as an opportunity to maybe unpack what is a very loaded word, understanding. And at Pair, you developed a few of these tools, Facet, SmoothGrad, you worked on attacking discrimination with smarter ML. But I really want to use these examples to dig in a little bit to thinking about, well, how you think about the word understanding. I think particularly as it pertains to ML, I've interviewed some folks like Bean Kim, and they've done fantastic work on the need for these human-centered approaches to explaining models, but then also the pitfalls of these. And so I'd love to hear your experience in developing these tools, but then also how you think about that perspective of we really do want to get people to understanding, but also be careful about some of the misalignment that can happen.
Yeah, I also want to say that there are certain words like understanding or intelligence that in this field it's hard to even use these words in a way that communicates to everyone, because I think people have genuinely different definitions in their head about what this means. And I think for me, I will say that like I at this point sort of believe that many of these words are just in the vernacular and are sort of informal words. And so instead of thinking about sort of an abstract concept of how can we understand models, I would say what can we do with models that's going to be helpful and useful and interesting, and then focus on sort of particular cases of that. And I think that will roughly approximate what people mean by understanding. But at this point, I feel like it's easier to kind of focus on sort of what we do with things and how we can be helpful. Um, is a good way to approach that. So I'm going to back up and talk a little bit about PAIR. So it's an acronym, stands for People Plus AI Research. And this is a group that Fernanda and I started uh, basically to look at, okay, there's more to machine learning than just beating benchmarks and getting to state of the art on some task. Uh, Instead, what you really want to do is think about, okay, how does machine learning fit into human activity in general? How can we like sort of center on people and think about how people are going to use this, how people can be part of sort of this broader system. And I don't think we were the only people thinking about this, but I think we were fairly early to kind of create a group that was based on this idea. And I think that one of the things that becomes clear, and this will all, if you try to unpack the word understanding, you see the same thing, is that there are just many, many different groups of people who want to do different things with a machine learning system. You might have engineers who are trying to figure out how to make their system perform better. You might have a doctor who is working with a machine learning system and wants to use it to be effective, but not get drawn into illusions or not to misunderstand it. You might have someone who is using a consumer application that is making predictions for them of some sort. And what is the right way for them to interact? Can we create guidelines for a designer of a consumer system? And all of those are really, really different use cases, but they're all really important. So we decided to basically tackle all of these at PAIR in different ways.
So I guess in thinking about some of these different examples, well, first off, I think one thing that kind of stuck out to me and what you said is this sort of fundamental orientation towards the systems we're developing. One thing that we're hearing more and more recently, and I think that there's really this more and more common back and forth between these almost end of history narratives and the idea of AI systems taking your jobs and replacing people, and then that other view of, well, let's center people and think about the systems we're developing as augmenting. And I think this also traces back to the path dependence issue we talked about earlier. It's really an artifact of the ways that we choose to build these systems, the ways we choose to integrate them. And so I guess I'm kind of catching one side of that in the way you think about these systems.
Yeah, I think at this point, this is such a complicated area. And you know, at one point I was thinking, oh, I should write a book about this. And I was trying to think about a title. And eventually, the only title I could come up with was, I don't know, and neither does anyone else. I was like, that book isn't going to sell. But I think it's important to acknowledge just how little we know. And for me, what I would say is that the best analogy, I think, is to imagine that this is something similar to the Industrial Revolution. And that we're at a point where maybe, the first effective steam engines have been, are being used, or maybe I don't know. And we're trying to look ahead. And the truth is, it's going to be a marathon. It's not a sprint. There is going to be a lot that is going to happen. I think there are short-term concerns, there are long-term concerns. All of it is important. And I think we need to just gather data, and sort of the more that we focus on people, the better as we do that.
I like that perspective. Let's talk about a couple of the other things you worked on in the context of Google. One of the really interesting ones was TensorFlow.js. And I know that this is really open source and very collaborative, but I'd love to hear a little bit about the birth of that project.
Yeah, the TensorFlow.js project, that I want to say that came out of my team. I personally probably deserve relatively little credit for that project. But one of the things that I love about that project is that it started in this kind of sprint that we held. Like, one of the things that Fernanda and I would do in pair is that we would make sure that once a year, the group would just take a couple of weeks where people would spend some time doing something completely new, maybe risky, just try something out. And actually, many of our best projects came out of that sprint process. It's something that I would recommend to anyone who is managing a group that cares about innovation in any form. And so basically, this came out of there's a set of prototypes. And then what was most dramatic to me watching the development of TensorFlow.js was that at every stage, so many other people who heard about it got excited. Like, there was clearly just this hunger to do machine learning in the browser in that way. And so watching that take off was important. And then it was always sort of an important value of mine and many other people as well to make sure that it was an open source project. That I think, and what was especially important with JavaScript is that there's a whole set of people who are not well versed in C++ or Python. And a lot of those people are people who maybe taught themselves how to code, are coming at this from a different perspective. Maybe they're coming at it from an artistic perspective. And by just the fact of having a library that let you do machine learning in JavaScript, you are suddenly allowing a whole wave of people to participate who are going to have a much harder time participating before. So as much as I think there's a bunch of technical beauty in the TensorFlow.js library, to me, what is really beautiful about it is that it was just genuinely participatory, that it increased participation in machine learning design and deployment. And to me, that's a very, very important goal. I think, I think a through line, sort of almost a precondition for successful deployment of AI in the world, is as much broad participation in the process as possible. I think that is critical.
I think that's really valuable. When I was just getting started in deep learning myself, I remember that I started off with the Keras library, and I think that does a pretty good job of this as well. But it was still a huge pain if I wanted to figure out how to set up things on, say, a virtual machine or something that had a GPU. There was this massive headache. I mean, I was a CS math major, I knew some things, but just figuring out how makefiles worked and having to set up other systems, or for example, at one point, I think I had to try to use Cafe, that Berkeley deep learning library system. And even just getting to the point where I could run any code at all was just, it gave me some of the biggest headaches of my life. And I think that the more and more that we can remove that for people, that seems really valuable.
Exactly. Yeah. Yeah.
You were also on the paper Google's multilingual machine translation system. And I guess part of this looked at sort of the visual analysis, raising questions about how tasks like zero shot translation were handled inside the model. And then also really interesting, I guess, looking at evidence for maybe shared representations within the model. I'm curious to hear a bit about your contributions on that.
That was a case where I think visualization was really helpful in sort of uncovering and telling the story about a really interesting fact. So the idea behind this paper, and again, I have to say there are a lot of authors who do many things on this. I was just one of a team of people here. Was that you could train a system on language pairs, like you might train it to translate from Japanese into English, or from Chinese into Spanish. I forget the exact pairs that were used, but then just having done that, you could, if you trained on enough multilingual pairs, you could end up translating between pairs of languages where it had not seen any actual training data, in a sense. And that was already kind of a very interesting result. But of course, the question is, how is it doing that? And one idea is that there was just this shared representation, something, I don't know, along the lines of what linguists have called an interlingua, a kind of universal single language that you're going into. I mean, the funny thing is that there's a 1949 memorandum by Warren Weaver on translation that is one of the foundational documents of AI. And he suggests this as a translation mechanism. He's like, well, maybe we're living in a building and there are all these different rooms in it, but there's a basement and they're all connected to that. And instead of like coming up with all these paths between the room, the right thing is just everyone goes down to the basement and meets there. And that's how we have this one universal language. Now, humans have never figured out that universal language. However, it did seem like there was some sort of shared representation. And in the sense that if you took a sentence in, say, English or Korean or Portuguese, say, again, I'm forgetting the exact constellation of languages that we studied in that paper, but I think there were a couple of cases, and mapped them and looked at the internal activation space, you would see that sentences that meant the same thing would get mapped into the same region, even if they were in different languages. So there was actually this shared representation, that there was, it's sort of grandiose and probably incorrect to call it a universal language, but there was something in common that it was getting at. Another interesting thing we saw in the paper, and again, visualization made this clear as well as analysis, is there were cases where it did not develop a shared representation. And that actually corresponded to situations where it turned out not to be able to do this kind of translation nearly as well. And so that was kind of cool that you could look at something geometric you saw in a visualization and actually make a prediction about the performance based on that.
That's really fascinating. One kind of analog that I'm thinking of right now is when OpenAI looked into, they had this blog post, multimodal neurons and artificial neural networks, that was looking at CLIP. And in its representation space, it seemed like there were clusterings of the same concept in different modalities, where they found that there were activations that would sort of light up when you had, for example, a picture of Spider-Man or the word Spider-Man or something of the sort. And I guess this isn't exactly, translation between different languages, but it feels kind of analogous.
Yes, I think that there's a theme since then of shared representations being present, and I am guessing, I'll say conjecturally, extremely important. Like it feels like there is this core thing that modern large language models and other models that are very powerful seem to do well, which is translation. And I will say that my experience in playing with something like ChatGPT is exactly that tasks that can be framed as a translation task, you know, very literally, like translating from English to French, or translating from bullet points to standard business English, or translating from a description of a Python program to the code, it generally has done very well for me. And, that does not cover the full range of cognitive capabilities, but I will say that anything that feels like translation seems to be something that these things do well at this point.
I want to very briefly touch on your contributions to TCAV, and I think we don't have to take a ton of time here. I did discuss this work in quite a bit of depth with Bean Kim as well, but I guess I'd love to hear a little bit about your contributions to this paper and your thoughts on it.
Once again, I would say Bean deserves huge credit here. I think, I think that for me, what was interesting about this was this idea of reframing, sort of thinking about saliency maps or thinking about attribution questions in terms of high level concepts, and then trying to think about how that affects people. And so, I think, one of the things I remember thinking about is like, okay, what kind of experiment could we run to show that this is actually giving us something that people could use? Thinking about, okay, what does it mean that we can have this linear direction that seems to have a high level meaning? How can we use that as an explanatory device? I think, like sort of this became very popular already with word embeddings in 2013, the idea that, or earlier maybe, that you have these linear directions that are meaningful. And to me, the message of that work really is that it's not just that you can exploit those linear directions to get stuff done, but you can exploit them to help explain to users what's going on in the system.
Another interesting takeaway from that paper that stuck out to me and I think relates to some things we were speaking about earlier was its comments on trust creation. That TCAV isn't primarily about creating trust, but because people are gullible, you can sort of convince them to trust things that they necessarily shouldn't. And I think the phrase it used, which I found a little bit loaded, was it's about revealing the truth, which I think is directionally right, but also a little bit of a loaded word. But I do think that trust not being the right word was absolutely an important thing to call out as well there.
Yes, yeah. And I would say that this is something that is a general question about trust and truth in neural networks. Like a lot of times you will hear people say, oh, we need to make our system more trustworthy. We'll do it with an explanation. However, it's possible the best explanation will say something like, don't trust the computer. So one of the things that we said in a later work, this is the sort of People plus AI guidebook that Pear put out, is it's not like your goal as a designer is to increase trust in your system. It is to calibrate trust, make sure that people understand the right level of trust to have. And I think this is one of the things that is very different about machine learning. So with a normal tool that we use, we just want it to work. And if it doesn't work 99% of the time or 99, whatever, like if it doesn't work the vast, vast majority of the time, it would just be a bad tool. It would be bad. And so when you're a designer, you often are thinking, well, like, I mean, if it doesn't deserve people's trust 100% of the time, then it would be super broken. So my goal is just to explain to people why they should trust it. Now with machine learning, we're in a very different situation where we're starting to get systems that are very probabilistic. Probabilistic systems that are useful have existed for a long time, but I think they're hitting the mainstream for a lot of consumers for the first time. And so people need to understand how to use something that is often wrong, and they need to know, like, I will calibrate my trust. Yes, it's often wrong. Sometimes it's right. Here's what I do. Here's how I test it. And I think that is one of the big UX challenges around machine learning in general.
That's an important call out. And one thing that I think Thomas Dieterich has kind of said about this too is that people will sometimes make analogies between, or maybe think of, well, how could I use a language model like a database, for instance, in uncovering information? But really, all that's going on in there is you actually have a probabilistic model of the database, not the actual database itself. And you would never substitute the former for the latter. But the problem then is many people aren't exactly aware of that. And the affordances that are given, the fact that I am hearing something kind of announced to me in a very confident way via text box. Well, it's likely that unless I know a lot about the internals of the model, or at least know a little bit more about these systems, my level of trust in that system could be miscalibrated, to use your wording.
Yes, exactly. Trust, and also knowing what to do when things go wrong. So one of my favorite examples with this that I think shows the complexity of design and why this is a whole new world is writing code with a large language model, or something like, let's take again ChatGPT, which I think a lot of the listeners are probably most familiar with. So one point of view that some people have is they think of these models as people. And there are a lot of reasons why that is actually really a troublesome thing to do. One of them is that you might just trust it too much. You might, if you get code, you just assume everything is going to be fine. And that's not true, because these things do make mistakes. There's another point of view, which is these things are just like tools, like every other tool we use. And that also is hard, because there's a really interesting failure mode that I've seen many times, where someone is writing code with ChatGPT, they run it, and they discover a mistake, and they're like, well, it just didn't work. Because, if you try to use a hammer and the hammer breaks in two, you're like, oh, that's a bad hammer. Okay, I'm not going to use that. In fact, if you have experience using these systems, what you learn to do is you just talk back to the system and say, oh, I ran that code and I got the following error, or I got the following undesirable thing. Can you fix it? And very often it will fix it. Okay. And that, in my experience, makes it many times more powerful than if you just expect a right answer the first time. So what's interesting to me is that the first two metaphors that as a designer you'd reach for, a metaphor of a person or a metaphor of a tool, both get you in trouble. And I think one of the exciting points of design right now, and probably for a while to come, is to figure out, okay, do we use metaphors at all? Do we come up with new vocabulary for this? How do we teach people how to use these things? I think it's a fascinating area.
I agree. Let's dive into this a little bit more. So, you recently published a speculative essay with Professor Viégas called The System Model and the User Model. And this is really all about AI dashboard design, which I think kind of coheres nicely with what we were just speaking about. So, I'd love for you to introduce some of the ideas in this paper and how that kind of came about.
Yeah, this is an interesting story, and I'm going to try to tell give the full history of the ideas here. So one of the things that I've been fascinated by, just at sort of an intellectual level, is with large language models, to what degree can we think of them as aggregating statistics? And a word that one hears is like there's the famous paper that refers to them as stochastic parrots and describes these as a haphazard, I believe, collection of statistics, versus are they doing something like trying to build an internal model of the world that they are encountering? And it's really unclear, and I don't what they're doing. It's hard to say even now, I think, but it's a really interesting scientific question if you start to operationalize this. And one of the ways that I try to operationalize it is saying, okay, are there internal is there some model that we could probe? Like, could we look at the activations as the LLM is chugging along during inference and make a guess ourselves as to what it thinks about the world? And I'll put the word think in quotes. I probably shouldn't even use it here. What aspects of the world it is encoding in order to make a prediction. So again, you could imagine that there's really nothing you could see that's interesting. Or you might discover there is some kind of crisp model of the world. So one, and people really have started to look at this. One piece of research that came from my lab is, and this was led by Kenneth Lee, is that we took a game. We took a simple game called Othello that many people like played in school. It's a simple game. It's played on an 8x8 board. It looks a lot like a Go board, but it's a much simpler game than Go in many ways. But it's got little black circles and white circles, and there's mildly complicated rules about what makes a legal move, and the board changes in sort of a mildly complicated way as you put down stones. And so we did a little experiment. We said, all right, we will train a language model. It doesn't really know anything about language, so we're thinking of it basically as a sequence model on just transcripts of Go games, both generated by people, but also ones that were generated by a computer playing against itself. And then we're going to see, like, number one, does it learn to make legal moves? In other words, if you give it the beginning of a game, will it predict the next move in a way that actually would fit um, the, the rules? And the answer is it does, which is weird because, again, what we give it, what we train on, are just transcripts. It doesn't know there's a game. It doesn't know there's a board. It just sees the squares where things get played. And that turns out to be interesting. And there's a whole other set of work where people have refined exactly what this model looks like and discovered it's even simpler than what we found in our paper. But it really feels like, okay, when you actually probe for this thing, not only does it make legal moves, but it's using a representation of the board to make those moves. And again, there's a complicated story. It is not a simple situation, but roughly speaking, it does appear to be that there's a model in there. Okay, so whether a giant language model has the same set of internals, I don't know, but we could start to ask, what if it does? What if, in fact, there are interpretable aspects of the internals of these models, and could we use those to our advantage? So let me describe another little story that leads into this history. So my collaborator, Fernanda, she grew up in Brazil, and she often will talk to ChatGPT in Portuguese. And in Portuguese, just morphologically, the language is such that you sometimes just have to make a decision whether you're talking to someone who's male or female, just the way certain words work. And what she noticed is that typically ChatGPT would start out addressing her as male, but there could be certain triggers where, for example, if she mentioned something about wearing a dress to a formal lunch or something like that, it would switch. And then from then on, it would address her as female. Okay, so that's sort of an interesting phenomenon. It's not wildly surprising, given that it is a good language model. You would expect an effective language model might do things like that. But now we can ask, how is it doing that? And if the answer is that there is some internal representation of the user where gender has just changed, that becomes interesting. You might think to yourself, it's cool that Fernanda can see that talking to it in Portuguese, but what about English? We might want to know. And then, this ties into other sets of work where we can say, there's work that shows that the system is going to kind of, in some circumstances, some of these models will tell you what you want to hear. This idea of sycophancy, where they kind of guess your political beliefs. And if you ask a political question, they'll give an answer tailored to you. And for all of these reasons, you might think, okay, probably it's important to know what the system is thinking of me at any given time. Partly so that I can interpret, so I can calibrate trust in the answers. You could imagine if you're concerned about safety, if you're concerned about, okay, wait, the machine is doing something that actually could have negative consequences and it's not obvious from the words I'm seeing on screen, maybe there's some way you could probe and get a sense of, oh, it's in this zone that is potentially, going to be dangerous. So for all sorts of reasons, getting a sense of basically how you are represented in the network is very interesting. There's a second, once you start thinking in this vein, there's a second representation that feels like it's probably primal, which is, how does the system represent itself? And for me, one of the things that I notice is that, these systems are good both at essentially what I would call producing content that looks like nonfiction or producing content that looks like fiction. And, when it's producing content that looks like fiction, it will talk about magic and it will do all sorts of stuff that has nothing to do with, what would actually happen in the real world. Whereas when it's producing nonfiction, it feels like it will do things like that less. Now, we know that you can't really trust everything it says, and there are certainly hallucinations, but it's almost like a different mode. And you might ask yourself, well, is there a real difference here? And would it be useful for me to know, if I think it is producing something like nonfiction, I'm asking it to summarize, a certain Python API or something. If I suddenly see, wait, it's gone into fiction mode, that might be a sign that something I need to pay close attention. So this is what we call the system model. So basically, and I will emphasize, this paper is a speculative and conjectural paper, but it basically makes the following. The premise is we can find models inside of these models within models, sort of the equivalent of a mental model, whatever that might mean for a large language model. And there are a couple of these things that are especially important. How the user is represented and how the system is represented. And then we say, okay, so let's think about how we might make dashboards. Because really all of the complicated systems we use in our life, and not even complicated ones, things like coffee makers, they're full of like little blinking lights that tell us about their internal state. Why shouldn't chatbots be the same?
So, first, I think among the things that you brought up, I want to talk a little bit about OthelloGPT. And Kenneth Lee actually wrote a really great piece for our magazine about this. And so I'm also aware that Neil Nanda, who does some really great mechanistic interpretability work, followed up on this. So for anyone kind of interested in learning more, there's a lot to see on this. But I just kind of wanted to get your thinking on the world model aspect of what was going on in OthelloGPT. So you were sort of looking at the probing technique that looks at this trained Othello GPT for kind of classifying tiles on this Othello game board, and you feed it model representations, and it does better when it's fed representations for a trained Othello GPT than for an untrained Othello GPT. And that is kind of taken as evidence that maybe there's something correlative, something like a model of the Othello board on there. And I suppose when I was initially reading that paper, the like really stubborn person in me saw the phrase world model and then really wanted to look for something like causal evidence there.
Yeah, I mean, one thing I will say is that we did do some causal experiments in there. So in particular, what we were able to do is we were able to take positions, sort of run them partway through the network under inference, then make a change that our previous sort of work here would change the internal model. So like a chip would change from white to black, and then that would change its prediction in the end in a way that was consonant with what we had done. And we made those changes even on, even things like illegal positions, which it could not possibly have seen in training, basically. And or I shouldn't say illegal positions, but positions that would be impossible to reach through any kind of game. So we knew for 100% sure we're not in its training data set. So I would say there was a causal link there. Now, I will say that there's been follow-up work with Neil and Andrew Lee that just came out where we're looking at sort of these even simpler representations that Neil found. And it is a complicated story where what you can see is that for much of the game, it seems like these representations are really important. It does look like maybe in the end game, it is doing something a little bit different. And all of this, I do think this dives into this idea that these systems, one of the things that I think is very deceptive for in that just scientifically in all of these things and why it's so difficult, why you say that there's like a stubborn part of you asking questions about causality. That is really good. We should all be that stubborn. And the thing that is, I think, the phenomenon that I think is pretty well established at this point is that when you have a neural network, it's usually doing some combination of memorization and generalization. And so if you are looking for sort of things that are perfectly general, you'll never find anything that's like 100% there, but you can often find some. And if you expect it to be purely, if you're looking for an example of where it memorizes something, you can usually find that too. You can usually find some evidence of generalization. It's very, very complicated. And so I think understanding the nuances is really important. And that level of skepticism is really good. But the skepticism, the way I would say the most productive kind of skepticism is to be in the mode of like, what's going on? Or is that really what's happening? Rather than, is that particular thing true? Or does this fit my preconceived notions? because you sometimes discover people are sort of skeptical in a way that favors their prior beliefs, and that's a thing to watch out for.
You're right about that, and thank you for reminding me of that detail. I do remember that experiment now in your paper as well. One, I think, other aspect of your speculative essay I wanted to discuss was kind of at the high level about the opportunities for dashboards and for interaction design when it comes to language models. And here, your concern is really, as you said, about dashboards for representing interpretable information about our model. And so the concern I'm about to present to you is maybe slightly different, but I kind of wanted to get your take. So Karina Noyan, who works at Anthropic, posted a pretty interesting take on this whole interaction design. And really, as I understood it, the main point was a lot of people are looking at language models today. And despite the excitement, there seems to be this kind of discontent with this is a really cool, powerful system, but I'm interacting with it via like a chat box. And it feels like this is just not imaginative. And what Karina kind of pointed out, though, was if you want to make a real interface innovation, you can't just play with the interface, but you have to train or teach the model itself the kinds of interaction patterns that you'd want to manifest. And so you might be able to kind of hack ways to make your interface more transparent, for example. But if the model itself can't faithfully self correct, if it can't faithfully reflect its reasoning, then these novel affordances are really, I guess, more charades than actually in tune with what's going on beneath. And I'm curious how you think about that aspect of interaction design.
Yeah, so I think there's kind of two directions to think about. So one direction is giving a user transparency into what's going on. And I think that's if you have some level of faithfulness, even partial, of transparency into a system, that historically has just been incredibly useful in all sorts of computer systems. In fact, every system. It's true of human systems too. It's like, why do people look at stock market indices? Like, that was a big invention, the idea of averaging all the stocks that were available or some important subset. And before that, people didn't quite realize, they had no way of seeing what was going on in the market. So in general, even partial kinds of transparency are just historically have been really helpful. So that would be the first guideline, I would say. But then I think there's a deeper issue, which is, okay, let's say we're designing the future user experience. Don't we want, if we see something, say, going wrong because of transparency, we want to change that. And we want to have a handle back. And that is something I would say my lab is thinking about. I don't know that we have any research to announce at this point, but it is something we're thinking very hard about, of like, how do we make this sort of a two-way process? What other forms of interaction can we get? I mean, I don't know what interaction is going to look like in 10 years. I feel like we're all sitting here like the only way to predict the future in some sense is to invent it. I think, but I do think it's a really good point, though, that we should think about sort of, I think the ultimate thing is going to be to tune the model to work with the experience that we want. But it's almost an iterative process, I think, where we're going to come up with new forms of transparency. That's going to give us ideas for new forms of behavior. That's going to turn back into sort of new ideas for the interface. And I have a feeling like we're going to circle around many, many times before we find sort of the best answer.
Bringing back that book title of I don't know and neither does anyone else, I feel like we're kind of in that state of we have the negative reaction to the kind of interface we have right now, but I don't know if I've seen, or I guess I don't know if I'd be able to articulate myself kind of a positive picture of what is that interaction pattern I myself want to see 10 years from now, for instance.
Yeah. Well, one thing I would say that I don't think the reaction is completely negative. I don't think it's fair to call it that. I mean, we have a system, and let's again take ChatGPT because people are especially familiar with that, where it got, I don't know, 100 million users in less than a year. I don't think it's very hard to argue that as a net negative reaction to an interface. Um, Now, of course, there are a lot of problems that we can see. And once we start using it, ways that we can be like, okay, that we would definitely want to improve X or Y. But I think it also is really important to acknowledge the popularity. And honestly, this is something I struggle with because a whole bunch of my career, as we talked about, was doing data visualization and specifically focusing on visual interaction as a primary way of getting information across. So a little part of me is like deeply disappointed at a chatbot being the big, user experience innovation. I'm like, all that text. Now, I think we can imagine it's easy to see that in the near future, we're probably going to get more options, but it is like it's sort of a sobering reminder, again, when I say like, watch out for things that confirm your own beliefs. Like, I don't know. I've spent decades thinking that the best user interfaces were going to be really, really graphical. And I have to look at ChatGPT and say, okay, maybe I need to say that text actually is very effective in a lot of ways.
Yeah, that's a really good call out. I suppose I wasn't trying to say that the overall reaction was negative. I just kind of focusing on the negative parts of it. But you're right that on the other side, I remember one very prolific Twitter user, Rune, wrote this article called Text is a Universal Interface. And so there is, as you said, on the other side, this very positive orientation towards the possibilities of text for communication and just declaratively as kind of a way of doing things as well.
Yeah. And I think where we are now, and I just think it's so fascinating, is that there is so much research in the HCI world of when you should, use GUI elements, when it makes sense to have text. And a lot of that, was done, I don't know, back in the era of Clippy the paperclip. And it just feels like, can we translate that to the modern era? Maybe not. I don't know. Again, and I think one of the big questions is like, there's so many intuitions that designers and HCI researchers have, and it's unclear which of those intuitions we can keep and which ones we're going to have to kind of refurbish.
The last paper of yours I wanted to discuss was this 2019 one on visualizing and measuring the geometry of BERT. And this is kind of getting us into something that shares stuff with what we were just talking about, but is slightly different. And so I'd love for you to maybe talk a little bit about the, again, genesis of this work, kind of the methodology you pursued, the work from Hewitt and Manning that you were building on here.
Yeah. So there's work from Hewitt and Manning that I read a paper that I don't know how to describe this except to say it kind of just exploded in my brain. It's like, I love this paper so much, where they were looking at BERT, so this basically a transformer model in which I'm going to dramatically oversimplify because we don't have a whiteboard here. But the model that should be in your head as you think about this is we have a series, we start with a series of word embeddings for each word of a sentence. Again, I'm oversimplifying key details around tokens and all sorts of things, but just bear with me here. And the model sits there and it at each step modifies those embeddings a little bit. And eventually it gets to a point where if you look at each of those embeddings as a point in a high dimensional space, there is a sort of linear transformation you can do. And then, remarkably, those points form a tree in space that is the same as the syntax tree, the kind of syntax tree you get if you diagram the sentence. And again, like, think about this. It's like we have this funny abstraction that people were, diagramming sentences in the 1800s, and then linguists came up with a bunch of ways of like, how do we formalize this? And then there turns out to be a dependency grammar way. And that literal diagram exists in a high dimensional space. And somehow your neural network has figured out how to extract that diagram. So I love this because just as I felt when I first saw the work on sort of word embeddings from Word to Vec, is that it was this translation of something that was part of human thought into pure geometry. And to me, that's very, very beautiful, because once something is geometric, there are all sorts of interesting ways that you can kind of work with it and process it, and it's just sort of intrinsically really interesting. Okay, so this was a very inspiring paper. So we looked at a couple of things with this. We're like, okay, so what is going on with these word embeddings? And so one thing is just looking carefully at what they found with syntax. There's sort of this funny mathematical thing, which is that the version of the tree they found, the way they found it is they said, look, if you look at the distance between any two words, like the tree distance in the syntax tree, if you take the square of the Euclidean distance between the corresponding embedding points, that will correspond. And I remember wondering, like, why would it be the square? Like, why not the actual distance? And this is a fun thing where actually, if you sit down and just fiddle around with pencil and paper for a while, you can realize that it's basically impossible for arbitrary trees to use Euclidean distance and tree distance and have it be consonant. And B, you can actually just sort of work out what essentially the unique solution is that allows you to have the distance be a Euclidean distance. And it's this very beautiful kind of embedding where everything is at right angles, which works in high dimensional space. Turns out, by the way, if you go back and look, and we have references in the paper, there are math papers from the 30s that talk about some of these ideas. They're often ahead of the curve. Okay, so basically we're able to say, here's the shape that these things take. And I will say there's been other follow-up work from Chris Manning's group that goes into more detail on this, and even tells you like what some of the directions might be, that maybe they correspond to syntax in very particular ways. Okay, so then there's also a part of this where he said, well, okay, syntax is one thing. What about semantics? What about the meanings of these words? And so we said, let's do something completely opposite. Let's look at word senses. So a classic question in natural language processing is, when someone uses a word like bank, do they mean a financial bank, a river bank? And word senses are very, very subtle. It actually turns out to be a very difficult task to figure out which dictionary sense of a word someone is using. And what we discovered is that if you find there's a linear transformation, again, a different one than the one used for syntax, that makes sense, which will let you sort of highlight the semantic, the meaning of the word that is being chosen in a way that you can actually build classifiers that at that point got state of the art against some standard classifiers for identifying word senses. And then just to tie in this idea of visualization, we created an atlas online called I think it's called the Atlas of Meaning, and it should be up today. Emily Wright created this. And that lets you type in a word and you can see a map of all the ways that different contexts in which it's used. Oh wait, maybe it's called the Context Atlas. So what I would say is, let me just see. Anyway, we'll follow up with that. And it will let you see, kind of create a map of meanings that in many ways is much more nuanced than what you would see in a dictionary. One of the things that like really stuck out to me is how it will separate sort of metaphorical and literal meanings of words. That if you type in the word lens, you get a map that is not just where you're very far away is like the lens of a telescope, from like, let's look at this in a sociological lens. And it's very cool to see all these things pop out and say, okay, I'm actually getting a visualization of language. So in many ways, I think this project tied together a lot of my interests, both interpreting what's happening inside of a neural network and then visualizations that end up, even divorced from the machine learning origin, give you a map of what words mean, which to me is like a beautiful thing to have.
It's really interesting to tie how powerful, how interesting these representations seem to, well, the basic kind of language modeling or masked language modeling task, and the fact that given enough data, it's actually able to produce a system that has these representations in the first place. I know that this is something we've known for a couple of years now, but it still never ceases to surprise me, I think. Just the interestingness of, we started with this very simple, let's predict the next word, let's predict masked words in a sentence, and then you get to something like what you found here.
Yes, and I think this is a really important point as more and more people use these technologies, and as we as experts explain them to people who are non-experts. And one of the things that I do worry about is that I see a lot of experts trying to explain large language models by saying the first thing you have to understand is that they are just next word predictors. Well, that's true in a sense. But although there's more that goes on with many of these things but I get. Let me just rephrase that. I would say people will often try to explain large language models by focusing on the next word prediction aspect. And I think people have this good motivation that they want to provide intuition for what's happening. However, just as you said, where you said, I'm always surprised by what they're doing, I too am always surprised by what they're doing. I think thinking of these systems as next word predictors is really not a great way of building your intuition, because their behavior is, it doesn't fit with that at all. For me, the moment where this hit it for me is, I think it was GPT-3, where someone had the example of asking the system to just translate smoothly between English and French using a prompt. And I never would have guessed that just next word prediction would lead to that. So, I don't know the best way that we're going to explain these systems to people, but I feel like next word prediction is a slightly deceptive way to describe it at this point. It's technically true, although once you add the training with instruction tuning or RLHF and stuff, it becomes less technically true. But it's so that there's certainly truth to it, but I don't think it's a great way of building intuition ultimately.
I'm totally in agreement with you on that. I think that it's kind of a little bit of a disservice to try to simplify all the way to just simple next word prediction. And I think that a lot of the capabilities we're seeing today, even since instruction tuning first came about, there's certainly a little bit more going on there. The last thing I was hoping to discuss with you was a bit of your artwork. And in particular, I love this visualization you did in the shape of song. And I guess in particular, and I'll make sure to link this so people can actually go look at it. But your visualization of glass was pretty interesting to me. And I think that, like, the only thing I've ever purposefully listened to by Glass was his violin concerto, which has a lot of really beautiful repetitiveness in it. And I know that I've accidentally listened to a lot of Glass because his music gets used in movies a lot. So it's kind of interesting, but I'd love to hear a little bit about the genesis of this project and kind of how you were thinking about this question of, well, what does music look like?
Yeah, so constant question in my career is trying to figure out, what do things look like, to observe things in new ways. And so I just gave myself this challenge at one point. I was like, I want to make pictures of music. Um, Again, not the first person to think about this, but it's a fun question. And one of the things that you can do if you look at a music score is you can observe that there's just a lot of repetition there. Again, it's not a novel observation, but there it is. And the thing that I realized is that if you visualize the repetition itself, so you took a timeline of a piece of music and you look at one section and just connect it with an arc to the next section where that repeats, if it repeats, you start to see this almost fractal kind of beauty in the music that is out there. And I think this reflects the deep complexity of the music. It certainly does not capture the full complexity at all. I think when I've talked to musicians about the visualizations you get from this, there often is a little bit of ambivalence where people say, but I can't hear anything. You're not really getting it across. But at the same time, there's just a surprise about the complexity, about just the patterns you get. And it becomes an exercise, one more exercise in translation, I guess. And, not to try to force too much of a metaphor here, I think it's a nice example of how looking at something very simple about the music, in this case, just repetition, if you do that at scale, more than any human would have the patience to do, but a computer can sit and look for every possible repetition in a long piece of music, it can create something that gives you a larger whole there, where it has these sort of emergent properties that come out. So, for me, this was a very satisfying set of artworks to do, because I would sit there and I would just I had a machine essentially. I could feed a piece of music in, and I could suddenly see this internal structure to it come out. And some of them were especially beautiful, and I was like, oh, like Philip Glass, everything he does actually looks really, really good. Um, and there are others where actually a lot of jazz is interesting, where at the beginning you'll see these very regular structures, and then it will hit the point where it sort of goes beyond what I think the computer can really process. And I think that's beautiful too, as a metaphor of, this moment where it's just like, okay, no robot is going to capture this. And I do like it, but I also think that again, tying into many of the themes we've talked about, it's this idea of something very simple repeated at scale creates a very surprising result.
I agree. It's interesting to bring that into the language of these different levels of abstraction. And at the lower level, as we said with next word prediction, the thing you describe, there's truth to it. It looks very simple, but then you kind of get the emergence of the complexity. Like you could very much, I think like Tolstoy kind of did this in What is Art when he was talking about musicians. And the way he described what they were doing was, well, they're getting really, really good at putting their fingers in the right places and doing that faster. And like whenever I practice violin, that is exactly what I'm doing. But then when you get out the other end, when somebody gets good enough, is Hilary Hahn playing the Sibelius violin concerto, and you're like transfixed in place listening to this. And so there's a huge difference between what's going on at like the pure mechanistic level, but then as in your visualizations, as in the models we deal with, what kind of happens when you start to put all that together into this larger whole.
Yeah, exactly. I think there's, and again, it exactly ties back into this idea of things having multiple scales. And I think that is just one of the big intellectual mysteries I think we're all trying to unravel, is to what degree do these systems reproduce these multiple scales? When do they not? Because I think what is really disorienting, I think, about this whole field is that we have these systems that we've built. We use things like very simple techniques like next word prediction to train them. And then they end up doing stuff that is really surprising. And they do it, through this sort of mysterious combination. Some stuff seems to be memorization. Some stuff seems to be going beyond that. We don't quite know what that is. To me, it's really, really exciting, actually. I think this is just one of the most intellectually interesting things to happen in my lifetime. So I feel lucky to be involved in it.
I agree. I think this is a great place for maybe a closing question and perhaps getting on the tail of what you just said. The things we're seeing today, some of the problems that we're trying to solve, really a lot of what you've done, for instance, is kind of at the intersection of putting together things that the AI scientists and the interaction designers and the HCI people are doing and how this all kind of comes together. And so what else are you sort of thinking about in terms of how you hope maybe things evolve when it comes to the interactions we design, the ways that we think about these models, the ways that we think about making them usable for people?
I think what I hope to see is people gathering more information. When I described a title of a hypothetical book as "I don't know and neither does anyone else," it's not meant to be nihilistic at all. Instead, it's about curiosity, I think. And what I'm hoping for is that our collective curiosity can kind of get us through this. That I think we need to acknowledge that some of the technology we have is just really strange. And we all use metaphors to try to make sense of it. But at the end of the day, it's its own thing. And I think the more that we can explore it, the better. So what I hope in terms of what I would like to see in the next 3 years for interfaces is lots of interfaces. I remember in the early days of the World Wide Web. So I was there for that, and that was my job. And it was really exciting to sort of see the early websites. And every website just looked a little bit different. Sometimes the navigation was on the left, sometimes it was on the right, sometimes there was no navigation. People tried all sorts of things. And that was really important. In the end, today we're at a point where I think most websites kind of look the same. It's a little bit tedious, but at the same time, we've kind of realized what works and what doesn't, which is very nice. But what I would do is I think about like this moment. Another analogy is like the early days of the web, and I think we just need a lot of exploration. And so, what I'm hoping is that we try different things, we see what happens. We don't necessarily prejudge what's going to work and what isn't. I think there are certain cases that are very high stakes where all sorts of things could go wrong, where we do need to be very careful and we do need to think way in advance. But I'm hoping that there are enough cases that are lower stakes where we can really experiment and just see what works and what doesn't. So I feel like that's the most important thing that I want to see is I want more observations, essentially. I think theorizing is interesting. I theorize for a living. I love to theorize. I want more theory too. But I think that as a field, there is way too much emphasis on coming up with a theory, coming up with a normative version of what the world should do, and not enough just stopping and looking around and saying what is actually happening. So I would like to see experiments to try a lot of things out, and I would like to see academic conferences being very friendly to pure observational papers that just say, look, we studied this thing and we saw this, we saw X. We don't know why it happens, but we did see this. And it was really important, and maybe someone else can figure out. And after there are 100 papers like that, we'll start to get the theories we need. But it's going to take a while. This really is a marathon and not a sprint.
I think that's a really fantastic message and a great place to end. So, Professor Wattenberg, I'm a really big fan and admirer of your work. I really appreciate what you've been doing and appreciate your taking so much time to speak with me today.
Great. Thank you very much. It's been a pleasure to be here and talk about all of this. And I will say, if any potential grad student is out there interested in doing a PhD program at Harvard, keep us in mind.
And that is a wrap, my friends. As I mentioned at the start of the episode, you can subscribe to The Gradient on Substack to receive not just this podcast, but also our articles and newsletters directly to your email. You can also visit us at thegradient.pub, where you'll find all of that, as well as more information about The Gradient and how you could even contribute if you're interested. And finally, if you enjoyed this episode, we would really appreciate your feedback. If you'd like to leave a comment or review, we'd love to know how we can make this series more interesting and informative to you. And with all that, I'll leave you until the next episode.